Hello, everybody. My name is Fanis Prodromou. I'm a Google developer expert for Angular, author of the Mastering Angular Reactive Forms. I know that today we have the Signal Forms, but this is at least the book that I authored a long time ago. Educator and technical content creator, senior Angular developer at the company ASI, co-organizer of the Angular Athens Meetup here in Greece. So today's talk, we will talk about an experimental API. So far, it seems to be like super robust and amazing API. However, this is still experimental. If you're going to start working with that, feel free to do it, but at your own risk, since things might change unexpectedly. So, of course, we will talk about the signal forms, introduction to signal forms, and I think that I have to change the title here. This is more like an in-depth introduction to signal forms. And I was thinking, what is the best way to explain to someone the forms, signal forms? And of course, we have to start small with a simple example, and progressively we will see a complex form. And it's very important also to see the mental model about the signal forms, because there is a mental shift compared to what we used to have with reactive forms. We'll also see the validators and the logic. The logic part is something new compared if we have a comparison with reactive forms. And we will also see how to split a form, how to grab a big form and split that into smaller parts. And if time allows, I do not have that bullet point, we will also see how to create a custom form component. So we will start like what I said, we will start small. We will see the login form, then we will see a user registration form, and then how to create a contract. We don't care about the details about the contracting, but what we care about is that the contracting system has a lot of information, many fields. And in that one, in the contracting system, we will try to split that. So let's start with the login form. So the login form, what we have is just an email, we have a password and a login button. Boom, that's it. Very simple one. And if we go then into the HTML, what we have is, again, very simple things. We have the input type email, we have the password, and we have the login. No matter if this is signal forms, template driven, or reactive forms, what we have to have in mind is that we need to have a model, a form model for that form. In this case, it is very easy to create the model, and it can be something like that. An interface, I named that login form model, where we have just an email and a password of type string. All right. Other than having the model, we also need definitely to have a way to keep the state of this form. How can we keep the state? So nowadays, since we have signals, what we can do is just to create a login model, which is a signal, a generic type of login form model, where we can have the email and the password, initializing them with empty fields, with empty strings. Nice. So far, we have nothing about signal forms. How can I convert that to a signal form? All we have to do is to grab this helper function, the form helper function, where what we have to do is to provide there the writable signal that we created previously. So this is very important. This is one of the key principles of the signal forms. They do not maintain their own data model. This is very important. We, the developers, are responsible to provide a writable signal, like what we are doing here, as the data model where the form will be based on. So any change to the form will update the writable signal, and any change to the writable signal, of course, will change the form. I mean, the UI. And speaking of the UI, how can we have now a binding of this form, since we created here that instant, we have the login form? How can we have a binding with my HTML? So what we have to do is to import the form field directive, and then go into my HTML and use that directive, where what we have here is the form field equals login form dot email, and then we have login form dot password. And please note that this login form is the instance that we created previously of the form. And this is the very first form. We managed, using signal forms, to create a very simple one, but we are not yet there. What we also need is to have validators. So let's talk about the validators. The validators are part of the second argument, where we can see here. Into the second argument, which is the schema, we can provide either an inline schema or predefined schema. We'll see details later. But what is very important, and I would like to mention here, is the root path. Why is it called path, and why is it actually root? Well, it represents the location of your form. And in this case, what we're doing is that we're accessing the root field, and we'll see details later about how to use that. Something very important is that either we have inline or predefined schema validators. Those validators are following a declarative approach. This is very important. So what I would like now to do, what validators I would like to have for this very simple form, is that I would like to have my email as required. I would like also to have my password as required. And you know what? I would like my email to follow a specific pattern, the email pattern. So these are the validators that I would like to have into this form following the inline part. So I would like now to do the following. The same form, I would like to see that in a different perspective, like a binary tree. And what we can see here is that we have root, email, and password. And despite that our form contains only two fields, what we can count here are three fields. We have the root as well. And whenever we have to work with signal forms, we have to take root under consideration. It's very important because we can work with the root as well. So what we said previously is that the schema follows a declarative approach. So you know what? How about now, if having this binary tree, how about if I provide some metadata to my email? And metadata meaning, you know what, I would like the email to be required to follow the email pattern and also to be hidden. The hidden is part of something that we'll see later on and has to do with the logic. And how about now the password? Same thing. I would like the password to be required and disabled. All right, so I have my metadata. How about now if I feed this one with some data? The expectation here is that at the time that we are feeding something with data, we expect to have an output. And the output in our case will be the state of every individual form field. And in this case, the email could be invalid, could be touched, could be hidden, and the password could be dirty, touched, disabled. How can we walk through the form fields? Because we're talking about the form fields, but how can I work there? How can I access a specific field? So to do that, we're doing that actually using the dot notation. The root in our case becomes, it seems that I have it delayed into the slides, the root becomes the login form, and then if I want to walk through the email, what I have to do is to go and be like login form.email. And if I want to walk through the password, again, same thing. I have to do login form.password. All right. And how can I access the state? Well, simply here by using the parentheses. And in this case, we have the login form. If I want to grab the state of the root, all I have to do is just to use the parentheses, login form parentheses. And the same thing is happening with the email. Login form.email to walk through there and grab the state using the parentheses. And of course, the same thing is happening with the password. And when I say to grab the state, I mean that we can have the value, the validity, errors, disabled, hidden, submitted status, and many more. So currently we're talking about the login form, and we haven't finished the validation of the login form yet. So let's access the state and let's provide some error messages into this nice login form example. And what I would like to do is just to provide this message: the email is invalid when my email is touched and when the email is invalid. So far, the idea is very close to reactive forms. This is what we used to do. The way that I'm accessing here the email is the thing that we said previously. Login from .email, walk through there, grab the state of the email, .touched, this is signal, that's why we need to have the parentheses. And as soon as this is true and the invalid is true, we're providing the email is invalid. All right. And we can do sort of the same thing for the button, where we can disable that. To disable the button, we have to grab the state of the login form, which is the root. Login form, parentheses, .invalid. How about now? If I want to display more error messages, what we have to do is to loop over the errors object, where we have the login form.email.errors. Grab that and then iterate over the errors array. Every error has a kind, and this kind of kind is a unique identifier of every validator. And this is self-explanatory. If the error kind equals required, we will display this field is required. And of course, we can provide more error messages. For example, if the error kind equals email, or if error kind equals to minimum length. Nice. And you know what? This works just fine. This works very nice. What I don't like though is that we have to revisit the HTML every time. We have to provide a new validator, a new message, or if we want to change the wording. We can improve that. And the way that we can improve that, got stuck on my end. All right. The way that we can improve that is that we can utilize the validator that we have already used. So here we have the required, and into the second argument, what we can do is to provide a message. For example, for the required, we can be like email is required, and for the email, we can have that email is not valid. So we can have the error messages there into our schema. And how can we access that? Well, to access that, again, we have to loop over the errors object and simply then just grab the error.message. And the HTML becomes much more cleaner. And if we have to do any change, we can do that just into our schema. So we are almost there to finalize the login part. What is missing is the submit functionality. So let's go there and see how to actually submit this kind of simple form. The submit accepts, there is actually to state it like that. The submit is a helper function from the Angular Forms signals that accepts two different arguments. The first argument is the actual form, and the second argument is the action handler. And in our case, the form is the instance that we created previously, which is login form, and the action handler has something like that, where we can have a try-catch block, where we can return undefined, or to catch and return a custom error. The crucial point here is this argument that we receive, the form. So this form here isn't just a generic object. It's, let's say, the validated raw value of your form. And Angular automatically ensures that all validation checks have passed before this arrow function is ever called. This is something like a green signal by Angular for the forms that, you know what, everything are okay with your form, go there and invoke your HTTP calls. So then, like what I said previously, we can return undefined if everything are okay. Otherwise, we can just return an error, a custom error. And to add a bit more implementation here, we can utilize the first value from, which converts the RxJS to a promise, and provide here, as you can see, form.value. Grab the raw value of the form and provide it there. If everything are okay, we return undefined. If not, we return a custom error. This is something that I really like. What we can do here is that we can grab the error message, the server error message, map that to a specific UI field. And in this case, hard-coded, I'm assuming that if something goes wrong, I would like to highlight as invalid the email field. The submit is just a helper function that allows us to make the actual call to the HTTP. This is not the event handler. And in any case, we need to have an event handler, something like submit form, where a user will click the button, will go there, and then of course, we will invoke the submit helper function with the details that we saw previously. And someone here will say, and wait a minute, why do we need to have all of this kind of functionality? Can we just have a wait here without the submit helper function? There are two very good reasons for that. One of them is that we keep the door open for the Angular team to provide more functionality into the submit helper function. And the other reason is that there is a submitting state that this is true as soon as the actual HTTP call is ongoing. And we can either disable the button or display a loading indicator. So we do not have to do something fancy to know if something is actually submitting. We have it for free by Signal Forms. And by seeing the submit part, let's say that we are closing the circle of the login functionality. And now let's go to the next one, the next part, which is the user registration form. And the user registration form, again, we won't see something complex. We will have the email, we'll have the password and confirm password. And the idea here is that those two fields should match, the value should match. And then we'll have country and state. And we will see more details about country state later. And of course, we'll have to create a registration form using the form helper function, providing a writable signal, and then we'll have to provide the validators and logic. What I would like to focus for the user registration form is actually into the password and confirm password. Like what I said at the beginning previously, is that password and confirm password should match in terms of value, and we'll have to mark the fields as invalid. And we'll see two different approaches of how to do that. Let's start with the very first approach. And in the first approach, we'll have to mark the confirmed password as invalid. How can we do that? Well, we'll have to create a custom validator. And we can do that using the validate helper function, where we can provide the path. This path actually is which field do you want to validate? In which field do you want to assign this kind of custom validator? And then we'll have a delay in my slides. Come on. All right. And then we'll have the context, which is something very interesting. So let's pause for a while from this slide and go there and understand why schema is, the context is very important. So let me say the following, that schema runs only once. And either the schema function, either inline or predefined, like I said, runs only once to set up the structure, okay? Since it runs only once, wait a minute, this is static. However, the validation logic needs to run every time a field value changes. So the validation must be dynamic. So we'll have static from one side and dynamic from the other side. And this is where the context plays a very good role here. It's the glue that binds the static with the dynamic part. The implementation of the custom validator is relatively easy to follow as an idea. What we have to do is just to have a condition. If everything are okay, return undefined. If something goes wrong, just return a custom error. So let's add a bit more details here. I would like this custom validator to be attached to my confirm password, and then what I have to do is to grab the value of a different field. So I'm using here the context, value of the password. So here we have the confirmed password, but in any case, I need to have also the value of the password, because I have to match both of them and see if the value of the confirmed password and the password are equal. If not, I'm returning a custom error, like what we can see here, where we have the kind. Otherwise, we return undefined. And please note that this validator is attached on the confirmed password, attached to the confirmed password, and that's why if we have then into the HTML to grab the error, we have to grab that from the confirm password field. So this is the approach number 1. Now let's see the approach number 2, where what we have here to do is to mark both password and confirm password as invalid at the same time. To accomplish that, we will use the validate tree. This is very similar to validate, but in a different functionality. And again, this is a custom validator. And the idea here is exactly the same thing. If everything are okay, we return undefined. In any other case, we return not just a custom error, but an array of custom errors. So the validate tree is a specialized tool, let's say, that validates a group of fields, a tree of different fields, all at once. Someone could say, can I use just the custom validator? Well, the standard validation puts the error on a specific field. However, with validate tree, lets you target multiple fields. And of course, the benefit here is it allows precise error targeting. So let's add a bit now more details to see how to use that. And as you can see, what I'm doing is that I have the validate tree, I have the path or root path. Since I'm accessing just the root field here, I'm grabbing the value and the field off, and then I'm comparing the confirm password and the password. If everything are okay, I'm returning undefined. If not, then I'm returning 2 different error messages, one for the confirm password and one for the password. Nice. So this is all about the password validation. Now, let's go here and let's see what is the business requirements of these 2 fields, where we have the country and we have the state. Well, the idea is the following. We would like to display the state whenever the country equals to US. And at the same time, we would like the state to be required. If I change country to Tunisia or Greece or whatever, the state should be hidden and not required anymore. So let's see how to implement that. At first, we need to have country as required. This is very straightforward. We're using required path.country, and then we have to have a custom, not a custom validator, a conditional required validator. If you remember, with reactive forms, that would be, I would say, hard to accomplish that. How can we do that? We have to have the value changes, add validator, remove validator, update value and validity, lot of things just for one case. With signal forms, things are very easy. What we can do is just have the required. What are you going to make as required? The state field. When the value of country equals to US. No more than that. So this is very easy to use. But according to the business requirements, what we have to do here is to hide this field, the label state. To hide that whenever the value is not US, or to invert that, to display the state only when the country equals to US. And this is just the condition that we have to use. And you know what? This works just fine. But again, what I don't like here is that we have to repeat the same condition both in TS, into our schema, and into the HTML. We can improve that though. An improvement should be to use the hidden logic function here. So we use a hidden function to conditionally hide a field. And a hidden field does not contribute to the validation, touch, dirty, or any other state of its parent field. Which means that if I hide that, will no more be required. And please know that the hidden adds the logic, but does not actually hide that from the UI. Again, we have to hide it from the UI, but this time, this is very straightforward. What we have to do is just to grab the hidden state from the state field. So this is about the country and the state and the business requirements of how to hide that. So let's now talk about the schema. Previously we said that we have inline schema and predefined schema. So let's jump a bit more there to understand what we have. I know that this seems to be a lot to digest. Don't try to read that. All I would like to highlight here is that this is my registration form, and despite that the form is very easy, we have only few fields. We have something like, I don't know, 20 lines here. And personally, I don't like to have this kind of code, a clutter code into my component. I would prefer to have this kind of schema in a different file. And of course, we can achieve that. What we can do is to create the registration form.schema.ts. And then we can just create a new schema like what we have here. Registration schema equals schema. This is the functionality that we have to have. And then we have to grab the validators and the logic. Just go to the component, cut and paste. And we will do it here. We will paste everything here into the registration schema, and then our component will become from this one to something like that, which is much easier to read. All we have here is my form model, and my registration schema. So having this kind of ability to create different schemas in different files, this is not about readability. Signal Forms is based and invests a lot of time into this kind of schema functionality because it allows us also to compose different schemas, which is an amazing way. Let me give you an example about that. Let's assume that we work in an application, and whenever we deal with an email field, we would like that field to be always required and to have a specific error message. Email is required, and I would like also the email to follow a specific pattern, the email pattern. And if everything goes wrong, I would like to have the email is not valid error message. So this is something, a convention, business convention in our application, okay? So now what we can do is start using that and compose this schema function with other schemas. And we can do that by utilizing the apply helper function. I would like into my registration schema to apply the email schema where into my path.email. And simply by doing that, we are composing different schemas. So let me now make up some requirements. And let's assume that the user registration form gives the ability to users to provide more additional emails. Something like, that will have a plus icon, and the user can click the plus icon, add an additional email, click again the plus icon, add an additional email, and so on and so forth. So we will have an array of items. But still, we would like every individual email to follow this kind of schema. To accomplish that, we can use the apply each functionality. We're providing here the additional emails array and then the email schema. And the email schema will be applied on every individual email field. And now, let's see how to create a contract. We have seen the user login, the user registration form, and now how to create a contract. And like what I said at the beginning, we don't care about the details about the contracting. All we care about is that perhaps we have plenty of info. Don't try to read that generated by Gemini. But in any case, we have contract information, we have client information, we can have scope of work, and internally we can have an array, something to click and add deliverables, or to click more and add a milestone. And if we continue, we can see that we have the project overview, and perhaps we can have terms and conditions. So you can tell that this is a relatively big form. And then this is what my writable signal looks like, where we have the project overview, the client information, contract information, scope of work, many things. So let me ask you now a rhetorical question. Would you prefer to have an HTML page having the raw form fields of the contract information, the client information, scope of work, project overview, terms and conditions? Would you prefer to have everything here in one fat file? Or you would prefer to have something like that, where you will have a contractor information as a separate component, client information, scope of work, project overview, and terms and conditions. And of course, this is much better to reason about and much better to debug and scale. And of course, this is what we will do. And please note here that we have form field. We are using the exact same pattern that we had for the other fields. For the input or for the text area and the other HTML elements. So here I have the form field, and intentionally I would like to focus into the scope of work, because here we have the business requirement to deal with an array. So we have from that component to mutate the complete form. So let's jump there and see how to do that, how to link the scope of work with my parent form. To do that, we're creating just an input. The type is field tree. We're providing here just our type for the sake of our intelligence. This is my form field. And then if you remember, we have to mutate the parent form. How can we do that? Well, let's assume that this is an event handler where we click to add a deliverable, and we're grabbing the form field, which is this guy, is a signal. That's why we need to have here the parentheses, dot deliverables, walk through there, grab the state using, again, the parentheses, which property state I would like to have the value. And then this is just a signal, which is business as usual. Do whatever you like, update that by providing the name, description, or whatever you like. And just by doing that, you are updating your parent form. And someone now will ask, and how about the binding of the HTML? How can I have that? Well, using the exact same flow. Nothing changed here. Again, we're using the form field directive, and then we're providing the path of the item that we would like to apply a binding. And here we have again form field with the parentheses, because this is the input signal that we grabbed previously. So let's now see a bit more abstract way of how to deal with the parent and children components. We can have a parent component, and then we're going to have, let's say, child1, where we're going to have the child1 component, and below every component we can have the child1 schema. And that schema is responsible for the details of that particular component. And then we'll have the same thing for child2. And how can we combine them now together? How can we compose them together? Using the apply helper function that we saw previously. Into the parent form, what we can do is to apply what child1 schema where into my child1, and the same thing for child2. And just by doing that, we are composing different schemas into my parent form. So, you know what? Let's jump now, and this will be the last part that I would like to share with you today: how to create a custom form control. So, if you remember with reactive forms, we had to do that using the control value accessor. And whenever you had to go there and start working with the control value accessor, we know it wasn't that nice. The experience, the developer experience wasn't that nice to do that. Let's try to create this kind of star rating component, where we have, currently we have highlighted only 4 out of 5 stars. Let's see how to have this kind of code. Okay, so here we have the star rating component. Currently it has nothing to do with signal forms. We have the rating, which is just a model. We have the stars, where we can, this will be a computed property to generate the stars array. We don't care about the functionality. And then something to happen when we click on a star, where here we have the on star click, which is our event handler. And then if we go into the HTML, this is what it looks like, where we have just a div class, star rating, a wrapper class. We are iterating over the stars. We are applying just a class, very simple things, okay? And then we have here the click handler, the event handler. And if we want to use that now anywhere into my application, what we have to do is just to grab the selector and using the property binding, rating, and provide the value 4. And by doing that, we know that 4 will be selected out of 5, which is the default one. But here, we talk about signal forms, and we are saying that how can I now convert the exact same component to be compatible with signal forms? The only thing that we have to do here is to change the rating to value. No more than that. Just by doing that, this is now compatible with signal forms. And if we have to use that, what we have to do is here to have the upstar rating. This is field tree. I have to change that. The API changed recently. Field tree, form field. This is the directive that we have to use and provide just the path. The exact same component, and the only thing that will change is the value. And I know that someone will be like, okay, it feels here the value to be a bit magic. Don't we have to follow a specific constraint? Yes. What we have to do is to implement the form value control, and by doing that, that directive will force us to implement the value functionality. And this is what I wanted to share with you today. And thank you very much for your time and attention. And if you want to elevate your skills more about signal forms, there is a 2-day workshop. The signal forms workshop won't be held by me, will be held by Mateus. And I will be responsible for the scalable architecture and modern reactivity. And you can go there, or you know what, you can go to angular.love page and you will see just the 2-day workshop banner. You can go there and you can see more details about this kind of workshop. Again, thank you very much for your time and attention.
Yep, thank you too for your time, and this is really for this insights too. Hope everyone learned something new today. So it's been recorded and it's gonna be on YouTube as soon as possible. And thank you so much, Faris, for your time. It's really amazing to have you. Yeah, thank you so much.
Thank you very much. Thank you very much
Okay.
for having me and for the invitation.
Thank you so much.
Thank you all.
Yep. Thank you all, and have a good night.
Have a good night all.